some reason I'm not able to move my window. Let's see. Interesting. Okay. Let me just use this. Um, Somehow my other browser window is not moving, so I'll just use a different browser window. Um, okay, I think everything is good. So I see lesser number of students. Um, Sorry for the white background, so, but we'll not stick to this page for too long. So hopefully, okay. Okay, so let's get started. I don't know. I mean, as I said, it's optional to be in the class because of lack of power plug points here. But so okay, so we are in lecture number 4. So in terms of where we are, so there are a couple of more lectures. Although we have several buckets left, but it's okay. We're not going to speed through things. So we'll go at our pace and adjust accordingly. So that also means that in about 20 days, you have your project report due. So I know some students have reached out to me separately about, during the week, like what's the scope and what can they do and what they should not be doing. So I'll just recap that for a couple of minutes and then we'll get into today's subject matter. So online audience, if you have questions, you can put it in the chat or you can always speak up, okay? Okay, so some reason. Yeah. Okay, so I just want to quickly comment on the projects. So it may be useful to look at this instruction sheet, which talks about what you should be doing. Actually, there's a lot of comments about, okay, what is the in-class presentation component? What is the project report component? How long it should be? Some details like that. And also, actually, for the thing that you turn in, which is what will be graded on, you will be graded on, not the presentation, which is in the last couple of lectures. So in terms of what you'll be graded on is also written here, like 3 components: clarity, content, and correctness, which is very generic, very broad. But whatever you pick up, whichever tool you pick up, for example, Streamlit or Docker, I mean, I'm not suggesting you pick those up because they may be, we're already covering in the class. But if you pick up one of these tools, let's say Docker, you should be clear on what you're trying to do. Docker is a pretty complex technology, but you should kind of investigate some aspects of such a tool. Okay, and some tools are not that complex, so perhaps you can cover many things. But for some tools, you can only restrict yourself to a few aspects of it. Okay. So clarity is just your presentation style is a professional debrief, basically. That it's like, let's say your manager or your team member asks you to kind of summarize exploration of a tool, maybe a vendor that you're evaluating. And so think of that as like a formal documentation of why that vendor was chosen or not chosen. Essentially, that's what we want to see. In the project report itself, you should ideally be spending as little as possible about the ML, about an ML aspect of any project that you're working on, in the sense that if you're doing some specific modeling, let's say predicting deforestation or predicting stock prices or something like that, that's just a small, you should restrict yourself to a very small discussion about that, in the sense, if at all it is necessary. For some tools, it's not even necessary that you have to talk about an ML model. Okay, so let's say you're just visualizing, or if you, the example slides had CVAT, right? So that's not, we don't have to talk about a specific prediction model, like, okay, we want to do object detection of cats and dogs and stuff like that. It's not necessary to talk about the tool. Okay, that you just have to talk about annotation capabilities, data, storage capabilities, metadata storage capabilities, and stuff like that. Okay, that's, so just look at the slides. But although the slides are just differ from the report, in the sense that the slides are more for a different audience. The audience is your other classmates, and you're just trying to tell them, hey, this is a tool, this is what it does. Okay, so that's different from a little bit different from a debrief that you're going to write, where you will be a little bit more in depth. Okay, here are the setup parts. Here are the challenges we faced. I mean, which is also something you can communicate in the slides, but in the project, you'll be more detailed and clear of what did you try with the tool. Okay. So it should not be centered to the ML aspect at all, like your other courses, most of the courses you worked on should be centered around the tool only. Okay. Any questions here? So I think here it just says, if, in case that Jupyter notebooks or requirements.txt or Docker files, if you write extra beyond the, downloading like a tool, like an open source code base or a binary, then they should be also attached with the report, so that it's kind of fully contained for somebody who's also kind of walking through your steps. Okay. Whereas the presentation is not like that at all. It's just a kind of a discussion, essentially an informal discussion of what did you try, and what do you feel about the tool and its use cases for you as a business analyst or a data scientist. Okay. You can mention those things obviously in the report as well, as I said. Any questions here? So I guess this is to summarize: do not talk about a ML modeling project. Okay, I know that that's predominantly the stuff in some of the other analytics courses, but we don't really, if you write it, it's actually a kind of a negative. It takes away from your focus on the tool. Okay, given the limited page limits and stuff like that. Okay. If you're still not clear, if you haven't picked like a tool to investigate, then you should reach out to me or look at the list in the projects candidates tab in the Google Sheets. Okay, so there are some projects that are suggested and some projects that are kind of suggested to avoid. So that will hopefully give you some pointers, but you can pick any tool that you think is related to machine learning or machine learning operational aspects of machine learning. Okay, so any questions here about the project? Because I don't want you to have a confusion till the last one day before and say, okay, what should I do? You should not be in that situation. Okay. So this is an elective course. So really the objective of this project is not to force you to do something for the sake of the class. Depending on your background, depending on your interest, and depending on which career trajectory you want to go to, pick certain tools that will help you, okay, to study. Okay, no questions. Then we'll just get into what we want to do today. Let me. Yeah, so what I'll do is actually go back to the Docker example a little bit more. I know I showed Docker last time, but it's such a Docker, or in general container technologies. I should keep using the word containers. Actually, containers and images and the idea around them is very pivotal today for in general software engineering, but also for machine learning. And so I'll kind of recap. Today's agenda is to recap. Creating Docker images and a few ways you can play around with it. I'll show it in a second, including there is a online playground. So the technology behind that is complex, but it kind of shows you how to, kind of get a look and feel for Docker. There's also VS Code Docker plugin, which lets you investigate what's the container that you've spun up, what's in it. As I said, a container is nothing but a process from an outside perspective, like Windows, if you go to Task Manager or Activity Manager, it's just a process. But from the inside, from the program's perspective, it looks like an operating system. Okay, so that's the two views there. So we'll try VS Code and play with Docker, just at least the mentions of them. And I'll show an example, project where, an ML specific project where you would, Docker is probably the simplest way to get it running rather than any other complex way to install it on your machine. Okay, so let's actually do that. Yeah. I think I have opened Play with Docker. So this is the website I was saying. So just to recap, right? What is container technology and what is Docker? I think I've spent like an hour last time. Basically, a box around your program and additional files, so that your program sees those files if needed, and those files look like as if it's an operating system from the program's perspective. But there's a bunch of files, and then the nice thing about this technology is that when in the rest state, which is called an image or a container image, the rest state is a bunch of files. So think of it as like a zip version of this collection of files. And so it's basically a zip file, and you can push it around, as in share it with other people through a notion of what is called a registry. Okay, so we didn't talk about registry last time, and we did not do an example of sending that file, the zip file, the image, from one place to another. But Docker, the company, for example, and not just Docker, Google Cloud, Amazon, and many other places. And you can also host your own, what is called a registry, where you can say, okay, here's a zip file for other people to use. Okay, so that other people can download from there. So Play with Docker is by Docker, the company itself. Kind of sponsored by Docker, the company. And so it's a playground which lets you play around with like Docker commands. Okay, so it's behind the scenes, it's running. It's running in your browser, and it looks like a terminal and so on. But behind the scenes, they're orchestrating it through some complex technologies. But from our perspective, it's basically a if you don't want to kind of install Docker, if you fail to install Docker, I would suggest, obviously, last time I mentioned install Docker desktop, which is a simple way it's a UI to see which images you have, container images, and which containers you're running from those images. So here you can so this gives you as it says in the previous as I said in the previous slide, or at the front page. So let me just let's look at the description. So it allows users to, you got the interface, so there you can run exactly the commands that we saw last time. So Docker build images, or Docker run particular image, and so on. So Docker run particular image will create the container for you. Okay, so it's basically, it looks like a virtual machine, but it's not. Because they're doing more things there. Yeah, it's basically a training site. So if it's really a nice opportunity to kind of play around with Docker without installing or messing up your system. And which will not, because everything is kind of isolated from the system except for the Docker program. Okay, so okay, we'll come back to this playground. This is kind of they set a time limit for this, so within that you can try out. So for example, right now there are no containers. So PS means list the containers, and there are no images here. Last time I showed it on my own machine, but it's the same idea. So if you wanted a quick, I don't care about all other things that I need to set up. If I just want to play around with Docker, I think this is a good starting point to play with it. Okay. Another way, and before I get into a specific example, we'll recap some of the Docker commands. The second way is to actually so this is the same. Let me just release that. So this is the same VS Code, I guess, folder or IDE open in my class folder that I've been using since the past several sessions. So I just moved a couple of, I think in the previous lectures, we had a PEM file and some other thing getting started. I think last time we downloaded it. But anyway, so we have our code repository, the first one. And we have a virtual environment in our local folder. Remember, that's where we are restricting our all sorts of packages like Flask and other things. And then yeah, so these are the three folders. I mean, last time there were a couple of folders. I just put them in a subfolder. Okay, so here, I think last time I showed you GitHub Copilot. I strongly encourage you to use it because it's free for students, as far as I know. And, it will give you a sense of what's the capability of today's modern deployed ML models, okay? So the GitHub Copilot is a product whose core thing behind the scenes is an actual ML model. So although we are studying MLOps here, we are not at a stage where that's easy. That requires massive amount of engineering. So that's one of the extensions. But the second extension if you go to the extension tab, if you have not installed this, so there's also an extension called Docker by Microsoft. Okay, so this is let me also close this. So Docker is extension for VS Code, lets you do basically the same thing as kind of equivalent to the same thing as what you would do with Docker Desktop, in the sense that if you have a Docker engine or Docker Desktop running on your machine, then you can also use VS Code to see what containers, what images are there in your machine and what containers are currently running. Okay, so in fact, yeah, so I think there's a nice tutorial here. We'll not go through the tutorial completely. Actually, yeah, let's not go through the tutorial right now. But I wanted to show. So you'll basically see a Docker symbol here. Okay, we are using Docker-based containerization, but there is alternative. Okay, there's a Podman based containerization stack, and there are others. Okay, so you basically, after you install this extension, you will see a symbol here, and if you click on that, you will get a different pane. Okay, you would not see this pane by default in VS Code. So what I mean, so you'll basically see a bunch of names here. I mean, help and feedback is fine, but basically you'll see containers, images, and registries. Registries is what I was talking about, like Docker Hub, or GitHub has its, Google Cloud, you can have a container registry and so on, right? And there's also a couple of other things that we did not discuss last time. So you can actually describe which network your container attaches to. So you can have multiple containers attached to a network, to the same network, which is different from the physical network that we are connected to. Like in the sense we are on UIC Wi-Fi, you could have a network between containers which is not related to UIC Wi-Fi. It's a virtualized network. Okay. Volumes we did not specify last time. Last time we were going through the tutorial, we only did like step one where we spun up a simple app. In fact, our prediction app. But volumes are a way to expose the host operating system's hard disk or any storage location. It could be S3, which is an Amazon's storage service, or it could be some other location, a storage location. So that can be exposed in the container as if the container sees that that's a local folder. Okay, so that's the notion of volumes. So networks and volumes play a big role after you know how to create a simple container from an image. Networks and volumes let you kind of really bring it to the next level in terms of, for example, containers. If you kill all the data, if at all you did something inside the container, that data is going to be lost. Okay, by default. But if you have a folder that's mounted as a volume in the container, even if you kill the container, the data is still retained and it persists. Okay, that's one of the sections in that getting started tutorial for Docker. So I encourage you to look at it. But for now, since I don't want to tangent immediately, so right now, looks like I do have a container running, Docker getting started. So let's see what images I have. So this is the image that we created last time called prediction. And I think right after the break, I also downloaded another image called Olama Web UI. So I think in the classes, I showed you that this Olama binary or basically an executable or a program, it also works with the client server protocol, just like Docker also has a Docker client and Docker daemon protocol, some interaction between them. So that was a web UI, was just a web browser based like ChatGPT type interface to talk to your open source LLM server. Okay, so if you were there in the second half, like a few minutes in the second half, then you would have seen that. Yeah. So and then Docker getting started is so I have 3 images, but you could download many images. You could have an image which is about Python. You could have an image which is exactly like Ubuntu, some previous version, or some other version of Linux. You can get those images from Docker Hub. Okay. Some of these images are free on Docker Hub, and some images companies can even charge if they're providing value. Okay. So yeah, so this is a container that was started from this getting started image. So what you could do is actually right click, and I mean, this is the same getting started container. So you could right click, and I think it opened in a different tab, but let me just yeah. So if you right click, you will actually see that the container's port was exposed to port 8000 in that example, and it's this is how, this is the default app. If you just go to Docker tutorial, this is what it will spin up. And how did we get to this point? We just ran this command. Okay, so let me just go back here just to kind of show it again. Okay, I just opened our terminal, and I'm just pasting that command. So we already have a container running, so we'll have one more copy of the container running because we are running, we executed this twice. So if you have any troubles, let me just put a different port. So 80 is kind of what is called a privileged port. So if you're a administrator or a root user or something, you can use that port. So I just increased it to 8001. Okay, so it's just a minor detail. I'm just saying, let's parse this command, right? So it's saying Docker. So Docker is this command line client utility. When we press enter, this command is going to the Docker daemon. It's a service that's running in the same machine in our case. Okay, it's a behind the scenes program that's listening to commands only from this command line utility. And what is this utility saying? And this is a very popular command to run. Popular command to execute. Run Docker PS, Docker images. These are all ways to query the daemon for saying, hey, what are the list of images? What are the list of containers running? And in this case, we are trying to run a container or create a container from a container image. And the image is called Docker/getting started. Okay. Where is this image located? By default, since we are using the Docker program, Docker by default says, okay, if the image is not there in local machine, let me fetch it from Docker Hub. But if you had a different registry, then you would explicitly add it to your system's Docker daemon service so that it knows where to fetch container images from, and then spin up containers. Okay. So if you run this, all you'll see is one more thing. So I think this one, which just started. It says here up less than a minute. So this is the second container, and you can run many containers if you want. But in addition to that, you can actually see what's at least in this UI with this extension, you can actually see what is going on in the container. Okay, so so this container has a bunch of files, and you'll see that these files, they don't make much sense. But if you've seen Windows Subsystem for Linux, if your environment, if you navigate around by doing CD and hopping up and down the directories, you'll see very similar set of directories. You'll see something called etc, something called opt or root, and so on. Okay, so this is just a kind of shows that the container is nothing but a collection of files from the outside perspective. At least the image is a collection of files, and when you spin up a container, you're just kind of showing those files to the program. In this case, the program is the JavaScript program that's running that getting started page that's actually being run inside the container. Okay, and not from Docker's website. So let's actually just to kind of last recap. So let's actually run prediction. I think in the prediction, I'm guessing it's 5001 from last lecture. So you can do prediction or prediction colon latest. We have one image here called prediction, and so we want to run a container based on it. So we can just click, we did the same thing. All we did is change the port that we want to expose because 8001 is already occupied. So 8002, and the prediction app I think is running at 5000. So 5001, sorry. So I'm just running it, and let's see if it's 5001 or 5002 in a second. Actually, yeah, we started it. We can actually see that perhaps here. So if you open, go to files. Yeah, in the I think we should look up the last time when we look at the Docker file, and we'll probably see it again if you want. But in the Docker file, we said working directory / app. Okay, so we navigated to the working directory / app and then copied our Flask app. So we can just double check that this, in fact, it's the same port. If you want to click here, it lets you see what is that file inside that container. Okay, so let's see. Oh no, it's 5002, so it'll not work. We map 5001 to 8002. So in that case, we can just stop the container and stop. Let's close this. And there's, you can do many things. You can prune the list here. So let's remove that container. So this is just an alternative to your Docker desktop. So I'm not showing Docker desktop because that would be the easiest thing. But it's basically mirrors the same idea. So we're just deleting and starting containers. So let's actually start with 5002. Anyway, just to kind of complete this section. Okay, so now that we started it, we should be able to navigate to 5002. Yeah, so question x is equal to 7. Oh, sorry, 8002. So 5002 is the local port, but 8002 is the port in our reference machine. So, I mean, the machine where the container is containerized, where the image is being run. So it still works, right? So this is a way to isolate. And so when I ran this image, I didn't need to have Python installed or venv installed or anything like that, right? So this is just running that Flask .py without any extra things necessary. Okay. Any questions about this? Or I know last time we did cover Docker. So if you have tried Docker before, then you should have hit bottlenecks, because the first time is always not so smooth. Any questions or comments or concerns? No basic questions. Okay. Okay, so if there are no questions, then we'll try out a harder container. So let's look at a more real world container, necessity. Okay. So for that, I want to, and this is just an example. I mean, don't worry too much about the specific repository here. Is just an example to show the power of containerization. So this is a fairly popular repository, as you can see, about 6,000 stars. And actually, you can see when were the files edited. You can see it was 5-6 years ago, right? So what is this, right? So it's a tool for detecting facial landmarks. Some of you might be doing, face detection and things like that in other courses. So this is a tool that also does the same thing. It kind of identifies where the lips are, where the nose is, where the eyes are for a face. But that's not very important for us. What I want to say is that if you look at this repository, this has a lot of files and folders to achieve building this tool for people. And it says here, what are different types of, I guess, programming languages that the vendor has identified. But that's okay. So, but if you come down here, actually, if you go up here, there's a notion of issues. And so higher the number of issues, the more problems potentially there are in terms of users trying to use this repository. And one of the reasons for that is, installation. So sorry, I don't want to focus on the actual tool itself. I mean, as I said, it just detects where the facial features are. Okay, so if you look at this, if you go to their GitHub, the vendor also has, in addition to storing a repository of files, you can have a what is called a wiki. I think everybody is familiar with Wikipedia, so it's just a place to kind of document what the project is about. And so they have a wiki with how to install and things like that. So you would have different formats of this, right? Documentation pages of different tools also have similar idea. So if you look at the installation, they have installation instructions for the different things, but they also have a quick start with Docker. Okay, and in this case, one of the users has actually put the zip file in Docker Hub for other people to use. Okay, so in this case, this is what you would get if you run that command. That particular zip file with this tool running, I mean not running, but if you clone that image and spin up that container, then the tool will be running on your machine without installing anything else. Just to see the complexity of yeah, if you look at, let's say, Ubuntu or Windows, there is a lot of installation steps. Okay, you install the compiler, which I don't know how many of you are familiar with compile languages versus interpreted languages. Python is just interpreted. There's no compiling step. But whereas C and C++ and Java, there is a explicit compiling step, right? And there is extra packages that need to be installed. Some actually linear algebra acceleration libraries involved. So there's like a lot of steps involved to get this tool working. Okay, this is just, I mean, you would think, okay, it's 5 minutes versus 1 minute. It's not. It's like hours versus 30 seconds. Okay, so yeah, so I would say just running this, for example. Let me just run it anyway. Let's go to our VS Code, shift insert, and I think there's an extra $1 in the front. So what is this doing, right? So there's a run, but there's an extra couple of commands, -it and -rm. -rm just means these are just extra, let's say command line arguments. -rm just means remove this container if it's not being used, like if you terminate it. And so this -it just means that make it an interactive terminal. So what does it mean? So currently I'm in the class repository. So class folder, and this is my local machine. So this has been the machine since day one, right? So for us, this currently, where am I? It's on my local machine. I'm on my local machine. I have my virtual Python virtual environment instantiated, and I'm just in some folder called class, right? But when I run this command, you'll see that I'll actually get into the containers command line. So firstly, it's gonna download a lot of things, which is actually downloading parts by parts, different layers or different steps, different parts of this zip file. And then once it downloads, then it's going to spin up spin up the container. So again, as I said, this is something that somebody generously put up in the public repository. It's very similar in concept to Git and GitHub as a code social coding repository. I guess social coding website, right? So it's the same idea. So let's just try this.
So is this going to create a new container after it's done running, or is it cloning to an already existing one?
Now we're cloning the container image, and we're going to create a new container. Yeah. So we could have said just download the image and don't create, but because we already called a little bit more downstream step of running the container, so for that it sees that, oh, locally the image is not available. So let's go and check the repository if the image is available. It did. It found the image and it's now downloading it. So it's just a in the recursive thing of, oh, if I have to run something, I need to have the image. The image is not there. Let me go download it. That's what we're doing right now. So yeah, this is a lot of download. In the meantime, I want to mention about another tool, right? So by the way, these are all like not essential tools. These are like, changes like OpenFace may not be exist tomorrow, or maybe it's a bad tool, but just as a case study. Yeah. So in the moment, for a second, I want to kind of talk about Dive, which is a tool to kind of improve your trust towards container technology, because it will let you at least explore what is that you built, right? So last time we had a 5-line Docker file. I can open it. Maybe let me just open it and then come back here. So if I go to my files, MLOps code examples, Docker examples, let's see. So if you recall, last time we had this, these 5 lines or 5 commands in our Docker file, which is what led to this prediction image, right? So this, if you saw in the building of this prediction image, there were like 4 steps or something. There was step 1, step 2, step 3, step 4, which was just, okay, starting from a reference image, which if it's not available locally, let's go to Docker Hub and download this reference image called Debian versus Slim. We could have changed it to something else like Python latest, for example. And then a couple of commands were run, right? So this led to the building of an image. This tool here called Dive lets you explore what are the layers in a Docker image. So the OpenFace image that we're downloading is pretty complex. So we can use a tool like Dive to actually see, oh, what is it composed of? Like, what did they build? Like, if you didn't have the Docker file, but you just downloaded an image from Docker Hub, if you want to get a sense of what are the layers involved, then a tool like this can be used. Okay, so this is just an example to kind of say, let's not install it, but let's just see the visualization. So it's basically showing you what changed from layer to layer. So on the top left, so you're just saying, okay, dive. Oops. I think I clicked it. Sorry about that. So in the top left, you say dive, explore an image name colon latest, for example. It will just show you what all steps, what all layers are there in that image, and what all files are different from one step to the other. In our case, all the differences, there's only one extra file that's being copied. Okay, this creates one extra file, one new file, and this update step updates some system, I guess, files, right? In particular, installs Python 3, and so there's some new files and some update going on. So these would be the changed files from the previous layer. Okay, the previous layer is this step. After that, there'll be a bunch of files that will change. After that, our file will be copied. Therefore, it's a new file, and that's it. So you'll just see those changes explicitly in your container. Okay, so it's just a way to zoom into your container. Okay. I think we are still downloading things. So in that, while we do that, let me actually go back to the Docker view. And so here you can actually, so if you see, let's go to prediction and let's right click and say view logs. Okay. So what you're seeing here, this text, is exactly the text that you would see if you ran the last example locally. Okay, so view logs actually shows what all got printed out when your container is running. Okay, so for example, so right now it says, okay, there was an x is equal to 7 request, right? So this is inside the container that there's some logging going on. Now, if we go back to our browser and let's say 14, right? So some prediction model, simple regression, 14 times 2 plus 2. So you'll see that log. You are able to see that log here. Okay. So think of this as like not an opaque one-off tool that you'll build and like you don't have any visibility into what's going on behind the scenes. You can look at the layers, you can actually look at the logs. Sometimes containers will kind of spin up and they'll crash. Okay, they'll crash because your commands are not correct here, for example. Right, so this command, maybe instead of Python 3, you forgot the 3 here, and maybe Python is not a command that's found in this image. Okay, then it'll fail, right? So how do you know that it failed? You should look at the logs. Okay, so yeah, so let me go back to that other one. So this is a lot of downloading. I should have done it before. Yeah. So that was an example of a real life example. Sorry, that is an example. Open face, we'll run it, but we'll not do the facial unmarking because that requires an input face image and extracting. I will show how to some new aspect here, which is that when we said Docker run, we said -it, so we'll be in the containers terminal. Okay, so that's the only new thing that we'll see. We can also copy files from your host machine into the container and copy files from the container outside to the host machine. Okay, so meantime, yeah. So in this, I mean, I just said view logs. That's going on here. So let's actually delete that. What you can also do is that actually attach the shell. So -it command, you could actually run it. There's a command line equivalent of doing this, but instead I'm showing through the UI. So you can do attach shell, and now you are inside our container, running container, the predictions container. So let's say, I don't know if Vim is available, but okay. So actually we are installing something inside the container. It's not going to be, it's not a permanent change because once we kill the container, it's gone. I just wanted to show. So you can actually open and in fact edit it, but then since our Flask app is already running, it's not going to live reload unless you put debug is equal to true and things like that. But I'm just saying that you can log into your container and make changes. Okay, although these changes will be ephemeral in the sense that you kill the container, it's going to go away. Yeah, I think PS command. So several commands are not available because it's actually a really small version of Linux system that's running. So if you started with a container, if you started with a container image like Ubuntu latest, then it will download. It will have a lot more utilities available from the get go if you log into the machine, log into the container. Okay, it's very useful. Like if you want to do something with Ubuntu, but you don't want to try out on your own Mac or Windows, like not do those versions, but just try out lots of commands and you're okay with messing it up, then you can actually just log into your container. You'll have a command line interface, but you can actually play around that way. Okay. You can also run an Ubuntu container and maybe even get a visual display, just like remote desktoping on using, like when you remote desktop into a remote machine, you can remote desktop into a remote virtual machine, could potentially remote desktop into a into a container also. Okay. Any questions about these? Let me just see if that wrapped up. Was yeah, it wrapped up. So what did I do, right? So um, since I ran this run command, it downloaded this huge image, and which you can see here. The name it's called OpenFace here. Yeah, so it's actually from 6 years ago. So this is just something that was snapshotted 6 years ago, still runs today, and you can just run that tool. I mean, how would you run that tool? There are many ways to do it. So if you actually look at the tool, so we are logged into that container that's running. So the container name is called, I guess, it's just called OpenFace, I guess. So if you go to, okay, let me just see what, yeah, cd build binaries. So this is where the programs are face landmark detection and feature extraction, things like that. Okay. So how do you actually extract these things? So you could actually copy a file, like an image file, into this container. And this can all be programmatic, by the way. You copying a file into a container is like Docker CP file name dot JPEG to the container name, which in this case is, you see that 6B 80 something. So you just need to pass that information. So where do I get that? You can just do Docker PS to get that string. So let me actually copy some file. So just so that okay, I have, let's say, the PEM file. Just for simplicity, I'll just copy that. I don't know if I'm supposed to you give username. See, that's not the. Okay. Oh, okay. I forgot the. Is that the right name? Yeah. So I'm just looking at documentation, which is. So you'll see some examples here. So for example, Docker CP container. So if you want to copy from the container to a local situation, then container colon location, and copy a local file into the container. It's container colon some location. So I think I probably did the correct thing, but I don't know if the location is correct. So let's actually go back here. Oh, okay. It should be. Yeah. So I mean, I just picked the wrong path. So you saw that we just copied into the main root, but you could change it to /home/openface/build or wherever the program is, so that you can run the program on it. Okay. So so generally you would run this. So this is a really example of a real world situation where somebody wrote this program 5 years ago, and the only way to run not the only way, but the easiest way to run the program is through Docker or containerization technology. Okay. So any questions about what we have seen so far? I'm just through talking about some new features, I'm just kind of recapping the Docker technology again, because it's a pretty versatile thing that you'll see in today's modern software engineering, modern DevOps. You can run Jupyter. So when, let's say, if your organization, your company runs a Jupyter hub, like in their on-prem data center or somewhere else, then even the Jupyter instance system potentially running in a container in some virtual machine in a cluster. Okay, so many of these apps are running in containers. Actually, most of the apps that you see today, not just ML apps, but everything else, most of them are running in containers. Okay. Okay, let's see. We are in. Okay, let's exit. So here we just logged into our prediction container. If we exit, it's not gonna. It's not. Yeah, the prediction container is still going to continue to run. Okay, so this is the container. We just exited it, and if you want to, so just delete this. So this container is still running. So we can again go back and say, okay, attach here, and you should be able to log in. It's the same exact thing, but the other container that we ran, the open face one. So that one here we are logged in. If we exit, it's going to get deleted. Okay, so whatever file we copied, all that stuff, it's going to get deleted. So let's anyway exit. So you see that one of the containers got removed. That's because we put a --rm when we created that container. Okay. Okay, any questions here? So to summarize, from the past 50 minutes or so, 40 minutes or so, we looked at play with Docker. So if you don't want to think about all the previous 3 lectures, or just want to get a feel for Docker, then play with Docker would be a starting point, because at least you don't have to install anything on your machine, absolutely nothing. You will get a kind of an interface where you can spin up, run these commands that I was showing. Okay, although I was running it on my machine because I have Docker installed, you don't have to have Docker installed to play around. Okay, that's what we saw. Second thing is VS Code has a interface integration through this extension called, the extension is also called Docker. Through that, you can see what images you have in your machine, what containers you have in your machine running or exited and whatnot. And also you can look at their logs. You can log into them, basically, which is what we saw. And we just saw a case study of OpenFace as an example of a situation where one of the easiest ways to get it running today, since several years have passed, but Python versions and whatnot, software has changed. Instead of recreating that, you could just spin up a container from that image. Okay. Okay, so what I want to do next is I want to briefly mention Kubernetes. I'm not going to demo Kubernetes because that's kind of, I wanted to do it, but I want to skip to the next topic today, and then we'll come back to Kubernetes. So what is Kubernetes? I hope I wrote the correct. Yeah. So let's just focus on like what is this extra tool, right? Because the reason why I'm introducing it is because both not both, sorry, major cloud providers, Azure, GCP, and AWS provide managed services to run this software. It's called Kubernetes, and there's different names in these vendors. The managed services have slightly different names, like GKE means Google Kubernetes Engine, or EKS means Elastic Kubernetes Service, or something like that. But basically, they run a version of the software. And what does the software do? This software makes sense when you don't want to babysit each container yourself, each image and each container yourself. So what happens is in an organization, the data science folks or the business science folks may have their own containers related to reporting or related to model building or data fetching or whatnot. The software engineers, if let's say there's a web app involved in your organization, then the software engineers will have their own backend containers, front-end containers, lots of different things. So there will be potentially hundreds or even thousands of containers. And so this software lets the DevOps team kind of manage these containers. Okay, manage in the sense that there's a way to. So this software makes a collection of machines look like a single machine from a user's perspective. User as in people who want to run containers. Okay, data scientists, web developers, backend engineers, all those people. Yes, they all from our perspective, it's going to look like a big machine where some program is running called Kubernetes. But behind the scenes, there's actually a cluster of physical machines or physical or virtual machines over which this program is orchestrating, where should the container actually run? If it has a certain RAM or memory or, certain hard disk or certain CPU requirements, takes care of reliability, replication. So if, because there's multiple machines involved behind the scenes, although from my perspective or user's perspective, it's going to look like a single program running somewhere. So behind the scenes, machines can fail. So it'll take care of that. If you want replications of your containers, let's say if your ML program is like only able to predict one output at a second, whereas you have a bursty traffic, you need lower latency, then you might want to have copies of your ML services, ML containers. Okay, so this program can let you do that replication, reliability, and in general, it is it's a part of Cloud Native Foundation. So a lot of big companies, both tech and most traditional companies are also now having a huge tech usage. So most of these companies are using this technology to deal with this explosion in containers. Okay, this is not the only technology. Docker itself, as a vendor, also has its own technology called Docker Swarm, which does kind of some same thing. So what do they do in one line? They are just managers, orchestrators of containers. Okay, these images and these containers, you want to kind of manage them in terms of which resources to use to which containers can talk to each other, which containers can actually see the outside world. Because if you remember, anything you deploy and is visible to the outside world, you need to be very sure that your right people are accessing it, and they have the right credentials, things like that. So all that can be taken care of using a software like this. Okay, so we will probably not see it today. If we have time, we'll come back to this. Okay. Okay, so what I'm going to do next, actually today's agenda is there are three things that I want to do, depends on the time, and we can kind of spill it over to next session also. Today's agenda is to talk about versioning. Okay, so that's really what I wanted to get to. I know the slide deck has got it. So after this, we are basically entering the next bucket. Like the first bucket took a long time, but that's not the only thing about MLOps. Many people kind of take away from this course, we should be deploying models, using web servers and so on. That's like actually one part of it, sure, an important part, but there's actually many, many other things that are very important in MLOps. Okay. The second bucket is talking about scheduling, versioning, and testing. Okay. So scheduling is actually a common type of thing with regular software engineering, which is to schedule recurring data pull, data push, model, training and things like that. That's what scheduling is about for us. Versioning, which is what I'm going to talk about, is you could version code, which is GitHub, and we'll briefly talk about it. But we can version our models, which is model trained today morning and model trained tomorrow morning. Maybe it's just a random number seed that started the training process, which could be the difference, but maybe one model is better than the other. Okay. So you can version models. You can also version data. Okay. So data also changes. Data is not a static thing. I mean, we know that with data warehousing and related ideas, we can actually figure out what is the raw version, what is the transformed versions, what is the things that are exposed to appropriate users, right? So you can have versions of data. And in ML perspective, think of a data set where you know that the label is incorrect for a few examples, right? You would fix it, but does it mean that you delete the previous copy completely, or do you somehow more intelligently keep track of these changes of the data? Maybe new data points got added. Okay, so So that's about versioning, code versioning, model versioning, and data versioning. Just 3 types, and there could be more, but and then testing. Testing is also there's some overlap with software engineering. In software engineering, testing means the software works as intended by the developer, by the product team, whatnot. Here, testing is, in addition to that, testing that there is actually an improvement. Statistical tests is what I mean here. So think of A/B tests or ABN tests or randomized control trials, right? So you test whether model 1 is better or model 2 is better, or option 1 is better or option 2 is better in general. So that's and since that is intersecting with statistics and therefore machine learning, that's what I mean as a testing component. Okay, those are 3 things. But let's just briefly look at versioning. So I want to start the story by talking about data versioning. Okay, so sorry, by talking about code versioning, because we've been seeing code versioning so much that let's talk about code versioning first, and then talk about the other versioning ideas. Okay, so code, models, and data. Those are 3 things. So let's start with code. I think I have a. Sorry, I'm having to jump a few slides here. Yeah. So let's talk about code, because this is just a common layer. I mean, this is not specific to MLOps, but this is just something that you might have seen. I mean, our course, material is in a basically in some sort of in some sense a code version control system. Okay, so Git is a code version control system. Mostly makes sense for textual files or program scripts and program files. So what we want to do, I want to briefly discuss this. So before that, I want to quickly get a sense of how many of you are very familiar with Git itself and GitHub, perhaps. Git and GitHub. How many of you are very familiar with it? Okay. So GitHub. So here are a couple of other names: GitHub and Bitbucket, and GitLab also is a $1 billion plus company. So these are all vendors who provide this version control aspect, okay, which is actually an open source software. Git is an open source software. For example, you saw that I was able to use the command git, right? So git is a command that's available in my computer, but it's also available on Mac or Windows subsystem for Linux as well. So that program is open source software. But the vendors, GitHub, Bitbucket, and yeah.
Bitbucket, what we are using was that it was used for collaborative code editing.
Yes.
And it was had previous versions of the code.
Yes. That's exactly what we're talking about. Versioning is versioning of the code, previous version of the code. Collaborative aspects is what these vendors bring. So Git itself is also collaborative, but it's a little bit more bare bones. And so these vendors provide a lot more features for collaborative editing, collaborative code review, collaborative many things, social aspects of it, and also some value adds. We can just see GitHub today as an example of such a vendor, because it's one of the biggest ones in this field, in this area. But there are others. Okay, you can actually host your own. If you wanted a front end for your Git repositories, there's also Gitea, and others. You can also host GitLab yourself if you want to. Okay. So this is like saying, okay, here's a tool, I can host it myself, like CVAT, for example. You can host it yourself and stop using a vendor annotation software, right? A commercial vendor annotation software. So what we want to do is we want to walk through a few kind of ideas behind this version control. Okay, so let's actually do that using let's say our own repository. Okay, this is not the code repository, but it's some it's a repository to give a sense of like what's happening with the Git version control, okay, with our code, right? So here it says there are 52 commits or 52 snapshots. So before I get into some details, right? So this is basically, you should think of it's paralleling Microsoft Office or Microsoft PowerPoint or even Google Docs. Like they automatically version control your text, okay? And so if you have a document every 5 minutes, maybe it's snapshot so that it knows. In fact, in our course, we have the Google Sheets page, right? So it's actually version controlled. So every time you make an edit, let's say you put an entry to your name, or if you enter your project name, I know who edited it and at what time. So I can actually go back to that version if needed. Okay? So that's automatically happening for documents. You can do the same thing even with Git, but at least in the vanilla version of it, it's a program which lets you manually control the versioning process, because it doesn't make sense to, while you're editing and writing a mid-sentence a command or a statement in Python, to kind of have a version of it to go back to. Typically, you would want to have at least a nice time point where some of the program works, maybe some features not there, then you commit it and you have a program running. Okay, so so there are 52 commits in this repository, but there could be other other repositories that more or less. So commits are exactly this, snapshots. Okay, so really visually you have to think of these types of version control softwares as in terms of like a graph. Okay, so what when I mentioned a graph, so there has to be some nodes and some edges. So nodes exactly correspond to these commits. Okay, so you start with the initial commit. Okay, maybe there's nothing in the directory, nothing in this project right now, or this programming whatever set of files right now. You start adding print statements. You start adding import statements. You start adding some other statements. So maybe after each one, you want to kind of explicitly say, hey, added import, hey, added print statements, or added logging, added XYZ. So you can make commits. Okay, so that's why and the arrows just denote from which commits precedes the other, which commit is related to its preceding and succeeding commits. Okay, so that would be a what is called a chain, or like a single sequence, right? So a bunch of nodes with edges between them, right? So that would be fine. And in fact, that is the situation with this repository, because I'm the only person working on this repository or this collection of files. So it makes sense. So all these 52 commits are basically just one after the other. It's like literally a very linear version control. Okay. Unlike that, let's go to, say, this one. This is an example, right? So this one, if you see, it actually has what are called 8 branches. Okay. So what does branches mean? Just exactly think of the same graph. It's actually a directed graph, because one commit precedes the other, another, a different commit succeeds the other. So there is actually a direction, right? So we know that more code was added, and so on. So it's a directed graph. In my code base, my MLOps, in our MLOps repository, it's a single line. Whereas in this repository, just as a random example, just an example. So this repository has 8 branches. Okay. So what are these branches? They are, think of the same thing, commit after commit after commit after commit, but now there's some parallel such commits also going on. Okay. You may say, why are there parallel commits? It's exactly because of this collaborative nature of code writing. Okay. Maybe programmer 1 or maybe data scientist 1 is working on the model definition and that type of script. Programmer 2 or data scientist 2 is working on the data pre-processing aspect of your model training thing. So they could be working on different parts of the code, maybe even different files, or maybe the same file and different locations, or maybe even same locations. But the same location is going to be pretty hairy, right? If 2 people editing at the same location, not in real time, okay, then there has to be some, there could be potential issues. But so these 8 branches just mean that it doesn't mean that exactly there are 8 people, but just means that there are different aspects that are being worked on for the same code base. Yeah, and they're all being version, but the intention is to kind of, intention is to eventually get to a version of the code which incorporates all these changes, all these evolutions of maybe features and whatnot into eventually one code that's potentially tagged as release version 1.0 or release version 3.0.0. Remember Flask, for example, last time we had in the requirements.txt, we said Flask equal to 3.0.0, right? So that's a major release. So 3.0.0 is just like a version number. And so before that, there might have been multiple branches being worked on by different people. Okay. So let's actually go back to mine, and let's look at, just to see that sequence of branches. Okay, I'm not gonna really spend too much time here. It just shows like what is the name of the name of this. So every branch comes with a name. Okay, so here it's called master, but it could also be use main or any name you want actually. So typically more modern repositories have the default branch is called main, and yeah, and you see each commit, what does it do? I mean, I have like very minor updates in this because this is more about chapter notes and text material. But if you go to that one, it has a lot of commits, a lot of people working on it potentially. And so if you click on one of these numbers here, which is a ID for what's happening in this commit, so it'll say what changed. Okay, some person, whoever made this commit added this extra string, right, Ubuntu latest, and removed some commented out text here, like this is a hash something going on. So this is what you can see. So this is an extra feature that this vendor is providing, okay, which is not, if you want to use it through command line, you can actually do git diff as a command line program, command line function call to check the same thing. Okay. So let me actually come back to this so that I don't digress too much. So the mental model is just a directed graph, in general, but most often as you're a beginner, you will pretty much be working on your own repositories, perhaps, unless you're collaborating in something, summary, and then you'd mostly have a sequence of commits. Okay, so at least you start with that, get familiar with it, that, okay, I'm snapshotting as I'm making improvement in my code. Then we can talk about the next couple of things. So with commit comes a couple of more commands called pull and push. Okay, so let me go to MLOps code examples. And what is this? Okay, let's actually close that. Let's also close this and go back here. Okay, so yeah, so this is our code directory, right? MLOps code example. You can see, okay, let me actually talk about these three things: commit, pull, and push. Those are the three keywords I'm trying to show first, and then we'll get to some other features. So to do commit, first of all, I mean, I want to see, okay, what is the status of this repository? I know this is a Git repository. This is my repository, with the code examples. So it says, okay, there's a extra file that you are not tracking in the version control system. Okay. That's fine, but let's actually do something else. Yeah, let me just go to regression because I don't want to complicate things. Okay, so this is, so by the way, if you did not see this version of the problem, so this version of the code in your version of regression, right? So if you downloaded the MLOps repository maybe 3 weeks ago and you did not see exactly this version, I mean, although it does the same thing, but if you did not see this version, then if you did a git clone command that I showed in lecture 1, then you can do just git you can just do git pull to update your code to whatever code I have, the most recent one. Okay. So if you only download the zip, then it's not a git repository. But if you use git clone to download the repository that we have for our course, then you'll be able to pull and push the code. So I can push the code because I'm the owner of the repository, right? It's under my username on GitHub. So I can push updated changes to my folder. Basically, repository is just a folder. And then you can pull from there, from that folder. So, okay, by default, if it's a public folder, which is a public repository, then anybody can pull. Okay, so you can clone the repository and pull from there. But since it's my repository, only I can push to that location. Okay, so it makes very natural sense, right? It's very similar to like sharing a Google Doc and saying some people are viewers and only the person who's the editor or the author can obviously edit the file, but viewers can always see the updated version. Okay, although that happens automatically in the docs case, here you have to pull and push to do that. Okay, so yeah, I want to let's say add some comments, right? So let me say check if X is in the arguments. Okay, so that completion came from GitHub Copilot. So I strongly suggest installing Copilot. But anyway, so I added a simple sentence here. And so now if I say git status, okay, I'm doing the command line way. This is not the only way. In fact, Visual Studio Code has Git integration as well. But before that, I want to show you git, pull, push, and commit. Okay, those are three keywords. So current situation, right? So git status shows what is the state of affairs of the code right now. It says, okay, hey, in your repository, I have edited last simple regression service. Okay. In fact, I can do git diff to see what changed. Okay. Git diff is saying currently these two files have changed, everything else is the same. And within that, the only thing that has been changed is this, and that's why it's in green. There's a plus and it says, okay, exactly the line that we added there. Okay. So that's what it changed. If you don't want to look at what changed, you can actually click here. This green thing in this editor shows you what changed. Okay. So okay, this is too zoomed in. This will show. Okay, I mean, since the line was added, it's showing that was line was added, one line. But if you had removed and added something, then it'll show the exactly what we saw in the web browser, right? So there was some green stuff and there was red stuff. Things were deleted, things were added, and so you would see the same thing with Visual Studio, Visual Code as well. Okay, VS Code as well. So we changed it. So what we can do is git commit, and so these are the steps you will follow. You'll see what the situation is, as I said last time. So the situation is there's one untracked file, I don't care about it. And then there's this is a modified file. Okay, so what I'm going to do is git add that file. So the way I'm going to add it is, so what does git add mean? Git add says add it to the, prime it to be snapshotted. So it's the snapshotting process, the commit process is a two-step process. It's preceded by a intermediate step called adding, because you may want to add specific files. Maybe you change 10 files, but you only want to add 3 files to this commit, this snapshot. Then the way you do it is add those 3 files. So with the add command, and then you do git commit. Oops, sorry. And then you do git commit. Generally, typically, you would also give a message. Okay, I can say added a comment to the regression example. Okay, so generally you would add a message, and this is a very typical format. And first time you're seeing it seems complicated, but it's not. So made a commit. Okay, now this commit is local. It's only local to my machine. I'm the owner of this report. I have a copy of this repository. I made a commit. Okay, added a comment, and I made a new node in that graph you're thinking of. Okay. Now what I need to do is make the remote location, that is the copy on GitHub, also see the same changes. I also have the same changes that are there in my location. Okay. So in particular, you can also see, like if I do git status, you can see that my branch or my collection of these nodes and edges, I have one extra commit or one extra node locally. That's what it's saying. Okay. So it already tells you, hey, there's a difference between what you have and what is there online. And so I can just do git push. You can add more extra arguments, but let's not add it. So by default also it'll do something. So git push now says, okay, since we are ahead in terms of we have new code changes that is at a committed location, as in there's a snapshot of it locally. I want to kind of ensure that the remote one also has the same copy. Yeah.
Professor, the commit only saves it locally.
Yeah.
What's the difference between committing and, let's say, just saving the
file.
Files.
Yeah, saving the file. What's the value of committing is to snapshot things. So right now you saved it, but then let's say you inadvertently change something, or if you want to do some experimentation, but you want to roll back, right? The whole point of versioning is rolling back. So if you don't have a rollback checkpoint, like, think of games also, right? You have to go back to some save location, right? So that's what we're doing here. That's the use for having a version.
Once we commit, the previous version would be automatically versioned, it says.
It's not automatic here. I mean, you can make it automatic with code versioning, but generally the automatic features make sense, are natural for documents like doc files and so on. It doesn't make sense for code, at least by default, because code is not, your incremental points, snapshotting points should have somewhat complete, somewhat working code, right?
Right now, since you have committed the changes to
Yeah.
the local file.
Yeah, and I also pushed it to the remote version also.
Yeah, so before pushing, is the version available?
Yeah. So yeah, exactly, right. So for example, if I say git status now, it says your branch is up to date. I have committed it. So let me use a couple of other verbs. And these are natural verbs. Okay, git log will tell you that this is that node which has the extra comment. Okay, because I have a message with this node. And before that, if you want to say, hey, I don't like this comment, I want to go back, roll back to a previous situation, I can go back to this previous commit where, it's a very uninformative message called minor, but you can roll back, right? So it's all available locally. So locally, you do have a whole snapshot, the whole branch or whatever, all the nodes of that graph are there. So you can jump ahead and backward anywhere you want. Okay. So what did we do? We just committed and pushed the data. So here we'll see that, I'm not the logged in user. This is some other user. I have a second username here. So you can see I just refreshed it. Oh, this is not the repository. Right, so there was a commit 3 minutes ago. So if you look at the commit trail, it's exactly the same thing that you're seeing in my website, right? So this repository is available for everybody to see. It's a public folder. It's only that since I own the folder, I can push and pull. I can push and make changes. Now, anybody can pull because it's a public folder. If it's a private folder, which is typically the case for many organizations, companies, right? So their folders will not be public, but internally teams can see, and developers or data scientists or whoever, ML engineers, they can download and upload and make changes. Okay. So what we've done is actually extremely basic. In class 1, we already did a git pull command. So let me just go back here. So git pull and git clone is similar. So let me go here. So you can see there are a couple of options, right? HTTPS and SSH. So this repository link is here. And so you can just go to okay, let me just go to so git clone would be the command to get that repository as a regular user, right? So this is something we've done in lecture 1 when we initially got our code base, Flask example, and whatnot, right? So yeah. So let's say that was me. So that was me making a change, added a comment, right? Now let's say this is another user. Okay, so this is where I want to introduce a second concept. So currently what we've done is commit. Commit is like the snapshotting process. It can happen either online on GitHub or here. And then we said pulling and pushing. Pulling and pushing just means exactly what you said. Pull means I just git clone. Git clone is actually just pull that information from remote location. Okay. Pushing means exactly what we did. Git push pushes my local commits to the Git repository. So what we're actually talking about now is not just versioning our data, but also collaboration, right? The moment we're talking about pulling, pushing, it's about collaboration, right? Because why else would you push somewhere else? Because you want to, of course, synchronize it with some remote location. and then hopefully somebody else synchronizes with that and works on different features and whatnot. So that's how it works in reality. Okay. The next thing I want to talk about is the idea of branching and merging. Okay. So we saw so far there's only one branch, at least in one of my repositories there's only one branch. In fact, even in my even in this code examples, actually code example there's 4 branches. The other one has 1 branch. So the next concept we look at is the idea of branching and merging. Okay, so I want to okay, so the way I'm gonna do it, let's look at branching first, and if we are running out of time, we can talk about merging next time. I don't want to take the whole 2.5 hours just talking about this, but I want to at least introduce to you at least the notion of branching. So let's go back here. Okay, so okay, let me delete that. Okay, and what I want to do is since I want to since I'm the owner of this repository, it says here it says I don't have access, but I do have access because I have the right credentials locally, okay, on my desktop. So anyway, let me just do git clone of that repository. So the difference between the HTTPS version and the git whatever version, SSH version, is you saw the word SSH, and that means that there is a key and a lock. The lock is with GitHub, a key I have, and therefore that's why I'm able to push my code to that location. Okay, so it's the same idea with the web servers that we saw before. So the HTTPS version, just if you download the HTTP, if you do git clone with HTTPS version, instead of having a SSH key lock, every time it will ask you for your username password to kind of push your code up on GitHub. So okay, so let's say I clone the repository. It could be same machine, different machine, right? So I go into that directory. So this is our directory here, and the directory that's open here is a different one. Okay, this is the first one is in the root class / MLOps, and the other one is in the second. Okay, so let's not worry about the second one. Just add one more. Okay, let's be in the class. Let's be in the class version. Okay, so what is branching, right? So let's say I want to develop a new feature. Okay, something, maybe I want to add an extra example, and I don't want to mess up any of these existing examples. Okay, so I want to create something new. Okay, so the way I can do it is I can create a branch and then work on it, and then I can say, okay, once I'm satisfied with this new example or new feature or whatever, then I want to say, okay, I want to merge it back to the original branch. Okay, let's say there's a canonical branch, which is what everybody downloads, right? So when we downloaded in the when we downloaded in this second location, if you look at git, if you look at which branch it is, it's called the master branch. Okay, that's the canonical branch. It doesn't have to be called master, but it could be called main or something else, whatever. But there's some default branch, canonical branch. Okay? That's what everybody downloads, and that's what everybody looks at. Now, if you're developing a feature, you can kind of basically you have snapshot. You're saying, oh, I want to copy that snapshot and do some development. Screen sharing is stopped. Let's see. Okay. Okay, I think this is a good time to take a break while I reboot this. So after the break, I will do another 5 minutes of discussion. I just want to show what branching is. I don't want to show other features that are there on the slide. So let's take a break for 10 minutes, and I'll just finish up the branching part, and then we can discuss. Yeah. Is it time? I think. Okay. So let's resume. So I just wanted to wrap up just the branching part and kind of recap today and stop, because I know I'm between topics. I know last time we covered Docker. Today, first half, I did cover Docker again, but just to kind of reinforce, right? Each topic is a pretty deep topic, and we are pretty much scratching the surface of Docker container technology. Same thing with Git. Git is a pretty versatile technology invented in early 90s. So a lot of decades, 30 plus years of people using it. Actually, it's a Linux kernel is kind of a big, is a really big Git repository with lots of developers working on different branches and so on, for example. So anyway, so let's actually go back to branching. So all I want to say was that we are in the, if you look at the second copy of this folder I have, its branch name is called master. Okay. I just wanted to mention that the branch name, master, main, it's all the same thing. Some unique keyword. Okay. And I have another bash terminal here in the class directory. I also have another copy of the same code, which I also git cloned in lecture 1. It also is on the same branch name. Okay, whatever it is. And so now I want to develop a new feature. I'm the developer of, since I'm the only developer, I could have just not worried with branching. I could have just write some new feature and just add some comments, and I could have committed and I could have done something like this. But the moment you have more than one, or even if you're a single developer or single person handling this, but if you know that you are doing a new workload, it'll have its own, it's a pretty complex thing, and it'll have its own new things going on, then it's better to branch. Okay, it's better to branch, work on it, have it ready, and then kind of put it back into the main sequence of snapshots. Okay, that putting it back is called merging, and the forking. I don't want to use the word forking, but the desire to kind of step away from the original snapshotting whatever path that's enabled through this branching process. Okay, so it's an analogy to trees. Okay, tree branches, roots, whatnot. So what we're going to do is git checkout. So checkout is a way to kind of define a new branch. So -b. Okay, and let me call it Copilot
Pilot is
example. Was it?
Say in VS Code, VS Code, right? We have to pay $10 per month for Copilot.
Yeah, but for students, I think it's free.
So $10 per month.
Are you using the UIC edu account? And
No, I'm using this simple VS.
no, but on GitHub, the vendor, if you show them that you're a student, you can just get it for free during that period. But if you don't want to use VS, if you don't want to use Copilot, there are alternatives. You can look into continue.dev. That lets you connect to any other LLM if you want to. Okay. Code completion LLMs. So actually, if you remember, we have I don't know if you remember or not, but we do have a code completion LLM running. Let me just. So if you remember Olama, right? So let me just run that. And sorry, I'm creating too many terminals here. You can see on the right side, there's 4. That just means there are 4 terminal windows. Okay, they're all kind of hidden. So if I list, you can see that I think one of the classes, I don't know if it was the last class or 2 classes before, I said we have a code completion LLM. So if you don't want to use GitHub Copilot, there is a way to kind of hook up VS Code with a LLM like this. Okay, this one can be run locally, right? So you can do Olama run deep seek coder. So this will just run like you will just get define a function in Python that checks if a number is I don't know, prime is kind of hard, but So, here it's an interface, this is all local, right? So this is not, you're not paying $10, but this may not even be correct, but it's just checking division by all sorts of numbers up to square root, perhaps, or some code. So this is just on the prompt, but you can actually intersect it with there are some extensions on in the extensions or in the extensions tab. You can find some extensions in the marketplace which can connect to this locally running LLM, for example. So you could.
It's given all the concepts.
I mean, that's because we did not ask it to be very, very concise and stuff like that. So this is what you would see even in ChatGPT and stuff, right? So it'll give you, hey, how do I do X, Y, and Z? It'll tell you what the command is, and it'll give you examples, and it'll give you all sorts of information about details. Anyway, some of it may not be even accurate. Okay, there's just some model that was trained by some bunch of folks. So anyway, so this is just so all I'm trying to say is that you can avoid payment if you want, currently at least. These are reasonably good enough that you can use them. So, but by the way, that comment about Copilot is not related to, I just wanted to name the branch Copilot, but it's not really anything to do with Copilot. I mean, it's just a random name I'm giving. I could have given some other name. So I'm just creating a branch now. So now, what did the branch create? It's now letting me, the next time I make commits, it's going to be different from the master branch. So now we have two branches, master and or main and Copilot example. Okay. So how do I see? So how do I check which branch I am in? Git status will tell you. It'll tell you a lot of things, but it'll tell you that you're on branch Copilot. And you can also check git branch to see which branch you are in. Okay. Now I'm using command line arguments to do all this. Another way to do it is actually by default, VS Code will have the symbol over here. So you can click on that. And generally it has a lot of functionality, but I didn't want to show all of them. But so right now it's saying that we are in this branch Copilot example. So you can click on it and it says you can create all these other branches, right? So let's not look at the UI. Yeah.
Is it possible? I'm assuming that since you created a branch, it was created from the master.
Yeah. Yeah.
Is it possible to create a branch from the branch?
Yeah. So look at so let's look at this, right? If you look at git log, so this program is very efficient. So since we did not edit anything, so the current pointer. So generally you can think of, you have a collection of snapshots. They're arranged like nodes in branches, and branches connected to each other look like a tree. So right now we had the original master branch, and it's like a tree with one bunch of nodes. And the way the program works is it's looking at one of the snapshots. I mean, it kind of maintains a pointer to one of the snapshots. Okay. So currently the pointer, which is called, I guess, head, is pointing to this branch called Copilot example. Okay. But it turns out that node or that commit or that snapshot is also the same as the master master commit. Okay. So it's not gonna it's not like copying the code it's not copying the code, because it's, why to copy the code? Because we haven't made any changes yet. So it's efficient that way. But to your question about, can we create a branch of a branch? Yes, we can. So you can have, in fact, let's see if, let's go back here, open face. Wondering if there are a lot of branches. Yeah, there are branches. So there are a lot of, GitHub classifies a lot of branches as tail and all that. So actually, you can't see, but there is actually, there are simple visualization tools. One of the tools actually being from GitHub, it's called GitHub Desktop, just like Docker Desktop. You can actually see the tree, like what are the snapshots, what are the branches, and if branches have branches. But you can visualize that tree, and essentially the tree is characterized by nodes, right? So nodes are, think of a graph, right? So directed graph. So there's a one main collection of nodes going from left to right in terms of timestamps, snapshots. And then there are branches, which are also snapshots. And you could have branches of that, which could also be snapshots. But generally, you don't want to have too many branches just dangling around. Eventually, you want to say, okay, I've finished the feature. Now let me merge back those features back to the main branch, okay, or master branch, whatever you want to call it. Yeah. So for example, this code, OpenFace has, there's a feature of something, light, Windows GUI, something else, model names. So somebody is, this person has worked on many different branches, and this is just showing a summary of how many steps behind, how many steps ahead it is with respect to the main branch. Okay, so let's come back here. So as I said, this one is now in the Copilot example branch. So this symbol, it says, this branch is just local. We just created this branch. It's just, in fact, in terms of pointer, there's nothing new created. It's just metadata saying, okay, it's the same snapshot because we haven't added anything. And but this branch is not present in the remote location, which is on GitHub. Okay, so we have to tell GitHub, hey, there's a new branch, which I have not done yet. But if we click that symbol, it will. But we'll kind of not worry about it for a second. And the remaining symbols are just committing. So exactly the commit, push, pull idea. Those are the symbols for that. So let's not focus on this tab for now. So what I'm going to do is make a directory. Actually, this is not very useful. But let's do it. Let's create a Copilot example directory, and let's go to a file. Right, so we have a new directory called Copilot example, and we just created it. So, and then what we'll do is in there, let's create a new file. Okay. Let's call it fast API example, right? So, and then we'll just rely on Copilot. Maybe it'll work, maybe it'll not, but we'll just say, it says control I, ask for something, create a code for touch illustrates. I don't know if that's a good word. Fast API. Okay, so so this is I mean, this looks exactly like Flask actually at this point. So, and let's say accept it. Okay, so this is the code we got. So it looks actually pretty much like Flask, except the import has changed from fast API, import something, and app is equal to fast API. So something changing. I mean, that's not the so Flask and fast API are web frameworks. So I mean, there's differences the moment you go beyond beginner level. But for this, for our purposes, it's fine. It's just a hello world example. So let's see if it works. Oh, we haven't even installed. Okay. Actually, I see VNV and base. So let's actually get rid of base. So VNV is our Python, environment. Okay, so which Python? We are in the right Python. Like that's the Python interpreter we want to use. And so let's use pip install fast API. What happened? Okay, so okay, so let me also check which fast API it is. Import. There are multiple ways to check this, but so 0.104.1. So let me copy that. Let me also create another file. Let's call it requirements. And I'll just, let's just, just to kind of keep the example complete. So what am I doing here, right? I just wanted a simple example of, oh, that did not work. Oh, we did not even have a app function calling. So this is not a complete example. Okay, but let's not worry about it. The code is not working. So this is just to show you that there are only two definitions, two function definitions: read something else. But there is no main, there's no main function to actually instantiate the app. Okay, very similar to Flask. But anyway, let's not worry about it. So now, if you look at Git status, it's not showing the, oh, because we are in the Copilot. You see that the Copilot folder is not being tracked at all. Okay, so first we need to add it for tracking, and then we will commit the current version. Although it's not working, but let's commit the current version. So we'll do Git. This addition and committing process, you can actually do it in one step, but let's do it like this: Git add, and then Git commit with a message, fast API not working. Okay, it's just to, you can actually keep it more, you have to make it more informative, but okay, we added this, right? So if you go now look at Git, okay, so now what we have is a new branch with a new commit. Okay, so now what we can do is, okay, we can go back to our code base. So right now there are 4 branches, but there's nothing active, in the sense that now the other 3 branches are kind of old branches and they've been already used. So if I do git push, so this will not work because we are in a different branch. Okay, so so it'll tell you that, hey, there's no branch on GitHub side which actually tracks this branch. Okay, on GitHub side, it's the same master branch that's tracking each other. So it'll also tell you what command that you need to execute so that there is now a new branch on the other side. Okay, so now if you come back to the website, now what we did is same, we created the upstream branch and it pushed that information. So now if we refresh this, we should see a Copilot example branch also appear here. All we did is create that branch, create some new files, and mirror it on the remote location, which in this case it's GitHub. Okay. Okay, so that's great. Now that's called branching, and that's just the very basics of branching: to create a branch, create some data. And now what we want to do is, again, now let's say we're happy with the fast API example, we want to merge it back. Okay, then the way to do it, there are multiple ways that you can do it in Git itself, but GitHub provides a way to do it, and it's called through the notion of pull request. Okay, pull request and merge requests, they are different names used by different vendors, but they all mean the same thing: to merge 2 branches. Okay, so the way we'll do it is go to pull request and new pull request. Oh, this is because I'm not a owner of this repository, I think. Yeah, I mean, I'm not the owner of this repository, so see, maybe I am. Let's see. Okay, it turns out I am part of this repository. Okay, so what are we doing, right? So we are trying to say merge this branch, Copilot branch, which has some extra files, right? So the Flask, so it in fact shows what did you add? You added an extra example.py file, and you added a requirements.txt file. That's, and it's saying, okay, you want to merge this branch back to this main branch. Okay. So create a pull request, and although this is not, we'll not merge it, but we'll just at least create a request. Let's call it example. And let's create, yeah, you can make a draft one, or you can create a pull request. There are multiple ways to do it. Okay, this is where I guess I was saying that this is not the right account, because I'm in a different account, which is not the Teja T account. And so you'll not be able to create a pull request. But if I was on my own account, I can create that pull request, okay, which is in a different tab. But what I want to do is show the same feature next time, so that I can recap the basics of Git and adjust the merging process next time. Okay. So to kind of give you, I don't want to talk more because there are only 20 minutes left. But where are we in the large scheme of things? We are talking about versioning. And within versioning, we are talking about code versioning, which is actually not very specific to MLOps. It's actually a more universal thing. So it's good to know that. And then next time, we'll talk about model versioning and data versioning. And then we'll also talk about a few more things, which is new to that lecture. So I'll introduce that later. but we'll break for now. So what I've not shown is merging, but you saw that merging is just choose two branches and click a green button. We'll do that next time. Okay. Once we have a more working example of fast API. Okay, so I'll pause there. Any questions here? So the first half is about Docker. Second half is just a versioning primer of code, which is a little bit more universal. Next time we'll see versioning of models and data. Okay, so let's pause here.